Welcome to this session. In this session, I am going to talk about solar energy. Solar energy. Solar energy is the source of all the life present on the earth. Without solar energy, we cannot lead our life on the earth. Most of the energy which is available to us that is provided by the sun in the form of radiation. We are getting food materials from plants and animals. Plants prepare their food materials by utilizing solar energy, and we are leading life on the earth because of heat. That heat is produced by the solar energy. Nowadays, we are using petrol and diesel, the fossil fuels for running automobiles. So these fossil fuels, these are formed from dead plants and animals in the deeper layers of the earth. Because of the high temperature and pressure, the buried dead plants and animals, they are slowly converted into fossil fuels. And when we burn these fossil fuels, the solar energy which is present in them, that is in trapped form, trapped solar energy, that is released upon burning the fossil fuel reserves. We generate electricity from strong winds, from water, by hydroelectric projects, and also from tides. Also we generate electricity. The driving force for all these is the solar energy. Solar energy, that is the reason for the earth's weather systems. Strong winds and strong rains, they occur because of the solar energy. And nowadays we have limited sources of fossil fuels, and we have to leave some fossil fuels for the future generations. That is the reason why we are looking for alternatives to the fossil fuels, and we are relying on the dangerous technologies of nuclear power for generating power. Nuclear fusion, these are the concepts on which we are relying on for generation of power from nuclear energy, but these are very dangerous. So these are not the real alternatives for fossil fuels. The real alternatives for fossil fuels is the solar energy, which is eco-friendly, and no wastes are created by utilization of solar energy in generation of power. Photovoltaic cells are the devices which are used for conversion of sunlight into electricity, and these photovoltaic cells, they work by a physical process, a basic physical process called as photovoltaic effect. When light strikes the photovoltaic cells, the photons will create the new electron hole pairs, thereby generating the electricity. So this is how photovoltaic cells work. As long as the sunlight strikes the photovoltaic cell, electron hole pairs will be created and will be getting the electricity. In photovoltaic cells, no materials are used, no reactants are used, and no products are formed here. No wastage occurs, and it is a renewable process. It is eco-friendly also. Solar cells are composed of various semiconducting materials like silicon, germanium, etc. Semiconducting materials, they are insulators at low temperatures, but when we supply heat or light to them, they become electrically conductive. Most widely used semiconducting material is silicon. Around 95% of the solar cells, photovoltaic cells, they are made with silicon. Semiconductor silicon, that is available in various forms like single crystal silicon, polycrystalline silicon, amorphous silicon, etc. Among these, crystalline silicon, that is used for manufacturing crystalline solar cells. And these crystalline solar cells, these are fragile, they are easily broken, and also they bend easily. Silicon is the widely used semiconductor, as it is the second most abundant element in the Earth's crust, and it also has the advantage of being available in sufficient quantities, and additional processing the material does not burden the environment. So processing of a silicon will not damage the environment. It is somewhat eco-friendly compared to other semiconductors, and main advantage of silicon is this is the second most abundant element which is available in the Earth's crust. For producing photovoltaic cells, semiconductors are contaminated by a process called doping. Doping is the process in which the semiconducting material uh, that is mixed with small quantities of impurities. Upon the addition of impurities, either extra positive charge carriers are created, or extra negative charge carriers are created in the semiconductor. So when we combine these two, P-type semiconductor formed by extra positive charges, N-type semiconductor uh, formed by extra or surplus negative charges. So P-type semiconductor layer and N-type semiconductor layer, if they are combined, they lead to formation of a PN junction at the boundary of the two layers. This is called as PN junction diode. This can be used for conversion of sunlight into electricity. Crystalline silicon that has a band gap energy of 1.1 electron volts. So band gap energies of other semiconductors, photovoltaic semiconductors, they range from 1 to 1.6 electron volts. So these are the band gap energies, and in this range, if the incident sunlight, if that has the same energy as the semiconductor material, then that sunlight will be converted into electricity. Okay, so without creation of extra heat, if the energy of the sunlight matches with the band gap energy of the semiconductor, then without creating an extra heat, electron hole pairs can be created, and electricity can be generated. Photovoltaic cells does not convert all the solar energy into electricity. The energy of the solar energy, electromagnetic spectrum, that ranges from 0.5 electron volts to 2.9 electron volts. But the energy band gap of most semiconductors, they range from 1 to 1.6 electron volts, but the total electromagnetic spectrum energy that ranges from 0.5 electron volts to 2.9 electron volts. So the sunlight that matches with the band gap energy of the semiconductor, only that sunlight is absorbed, that is converted into electricity. For example, a red light has an energy of about 1.7 electron volts, and blue light has an energy of about 2.7 electron volts. Most photovoltaic cells cannot use about 55% of the energy of sunlight, because this energy is either below the band gap of the material, or excess energy, or the energy is excess. Okay, less than 55% of the sunlight is absorbed by the photovoltaic cells for generation of electricity. Different photovoltaic materials, they have different energy band gaps. Photons with equal energy to the band gap energy are absorbed to create the free electrons, thereby generating electricity. Physical and chemical properties of silicon. Silicon is the most abundant electropositive element found in the Earth's crust. It is not a pure metal, it is not a pure non-metal. It is a metalloid having a luster property just like metals. So silicon is a metalloid with metallic luster. So it exhibits shining It exhibits a shining property similar to metals, hence it has marked metallic luster and it is very brittle. It can be broken easily. Silicon, that is another property. Next, coming to the chemical behavior of silicon, it mostly or usually forms tetravalent compounds. Sometimes bivalent compounds are also formed by the silicon. It is purely electropositive in chemical behavior. However, penta-coordinated silicon compounds, hexa-coordinated silicon compounds are also known to us. In elemental form, silicon, its physical properties are somewhat similar to metalloids, especially the physical properties of silicon. They are similar to germanium, which is also a metalloid. In pure form, silicon, it acts as intrinsic semiconductor. Even though we can increase its semiconducting property greatly, it can be increased by adding small quantities of impurities by a process called as doping. Doping by doping process, we can increase the conduction of silicon. Silicon in chemical behavior, it is similar to metals. Metals are mostly they are electropositive. Silicon is also electropositive. So the chemical behavior of a silicon, that is similar to metals. Another property is Another property is electropositive nature. The electropositive nature of a silicon is somewhat similar to tin, and the electropositive nature of silicon is greater than the electropositive nature of germanium or even lead also. According to this metallic character, due to this electropositive nature, silicon mostly forms tetrapositive ions, whereas covalent compounds are also formed. Uh, it also appears as a negative ion in some compounds. That negative ion, it is observed only in a few silicides only, and mostly it is electropositive in oxy acids, complex ions. It is electropositive in nature. Only in few silicides it carries a negative sign. Another property is that silicon forms various series of hydrides, various series of halides containing silicon bonds, and other compounds containing oxygen, uh, compounds in which uh, silicon has ionic property, and also it forms compounds with covalent properties also. These are the physical and chemical properties of silicon.